This video will illustrate the AGRI-vator rotor shaft maintenance and repair, as well as the mechanics involved with the overall assembly and disassembly associated with it. Before taking the following steps to service any machine's rotor shaft, please thoroughly clean the machine, remove appropriate covers, guards, and belts. If the AGRI-vator does not have a seater, the rotor shaft is accessed easiest when the machine is rotated on its back. A forklift with a minimum capacity of 5,000 pounds and 2 sets of chains can be used to rotate the machine. As shown here, carefully wrap the first chain around the mast of the forks to prevent the primary lift chain from sliding off the forks during rotation. Notice how the lifting chain is wrapped around the forks. This is to prevent the chain from moving laterally during loading. With the chains properly routed around the forks, the forklift is positioned behind the machine as shown, and the lift chain can be secured to the lift pins. To ensure safety, make sure all personnel is clear from the machine when rotating. Carefully lift the AGRI-vator until it is just over center and slowly back up while lowering the forks as shown here. This is the best time to inspect each rotor and feel for any lateral play. If excessive movement is felt when applying a load to the rotor, it may be time for a replacement. All rotors that need replacement need to be labeled at this time. It is often beneficial to break the 1,000 foot-pounds of torque while the shaft is in the frame. Once the nuts are loose, a paint marker should be used to label each of the components going down the shaft for easy reassembly later. Using the same chain and forklift setup from earlier, the rotor shaft can be lifted from the frame by attaching the chain hooks to the rotor channel shown here and lifting once unfastened from the frame. A proper inspection of the AGRI-vator frame must be done. Everywhere the rotor shaft was fastened lies the potential for fatigue damage. If the rebuilt shaft can't be secured flush against the damaged plate, a new one must be ordered. Distance between support plates must be checked. Measure, record, and compare the distances with what is required in the operator's manual. If the measurements are off more than a 32nd of an inch, shims must be requested from the manufacturer. In a clean work environment, unstack the shaft and lay each labeled component out as shown here in order. Note the parts are numbered in order for easier identification later. Any damaged spacers, stampings, bearings, or fasteners should be identified and ordered in time for reassembly. Spacers especially should sport machined ends as shown to ensure proper assembly. Next, we address the disassembly of damaged rotors. The outboard seals are removed first, followed by the snap rings. The snap rings can be reused, however the seals must be replaced. To prevent rotor damage, it is highly recommended that the proper press tool be used from the manufacturer. As seen here, AG2 only contacts the outer edges of the bearing while clearing the hex adapter through its bore. With the bearing removed, it is now time to inspect the bore of the rotor. The principal loading of the bearing occurs on the marks shown on the bearing, which translates to the rotor's bore seen here. Each area should be measured multiple times clockwise. Compare the average measurement with what is seen on the screen. If the bore is found to be out of tolerance, a new rotor must be ordered. If the rotor can be reused, prepare the area for assembling each rotor one at a time. This will ensure all the parts are used and not accidentally omitted during the assembly process. The snap ring is first inserted into the bore, followed by the new bearing adapter assembly. Again, it is critical that the press tool AG2 be used here to prevent damage to the bearing's internal components. The assembly is followed by the last snap ring and then a generous amount of grease. The grease is a lithium-based POA grease which helps block trash that passes the outboard seals while offering a safe fluid environment for the bearing to operate. Before flipping the rotor to finish, gently press the outboard seal into place as shown here and just repeat the process on the other side. Before stacking the shaft assembly, it is very important to be familiar with the timing of the rotors. Each of the bearing adapter assemblies has two timing marks located on two flats of the hex 180 degrees apart as shown here. When the rotor shaft is being stacked, each successive rotor will have its timing mark facing the timing mark of the rotor beside it. This is illustrated in the parts book similar to what is on the screen. Also, it is vital to notice how the shaft spacers fit over the shoulders of the bearing adapter assemblies. While stacking the shaft, ensure the spacers slide over these shoulders to prevent damage during stack-up. Before stacking the shaft, label the two flats being used for timing the rotors. This will help eliminate any confusion if the shaft gets bumped or turned during the assembly process. Highlighting the timing marks is also highly recommended. With all the parts laid out in order, check to ensure everything is accounted for and ready for the final assembly. When beginning the stacking procedure from the pulley end of the shaft, it is very important to have the hanger bearing assembled with all its hardware in place while stacking the shaft. The pulley prevents the carriage bolts from being installed later. Notice how the timing mark corresponds with the flat that was labeled, and the spacer is made to fit over the shoulder of the bearing adapter assembly as discussed earlier. Simply continue stacking the shaft and timing the rotors until the final nut is ready to be torqued. Remember, the operator's manual does show an assembled view of the rotor shaft if there's any questions about the order of the spacers or rotors. The nuts retaining the rotor shaft assembly is finished with 1,000 foot-pounds of torque.